Welcome to a lesson with Dr. Powell. Let's talk about the idea of variation. This is simply just wording that appears in word problems. We're going to go through what it means. Sometimes we see something varies directly as something else. Here I just inputted y and x, but really they could be anything in the sentence here. But essentially we're going to be looking at these ideas: varies directly as, which is actually equivalent, synonymous to saying is directly proportional to. So this has a meaning. Let's look at this word proportional. Proportional kind of means a proportion of or a fraction of. Well, any number is a fraction, and of means multiplication. You can think, so a proportion of something else. So y could be 1/2 of x. So you could simply write down this. And in this case, y is directly proportional to x since it's a proportion of x. Or it could even be equal to 5x. 5 is the proportion, 500% of x. So here, that's what this means. It simply means that y is equal to some constant times x. This constant is called the constant of proportionality. Often it's represented with a k. And it's a unique constant in a particular situation that perhaps we need to solve for. And oftentimes that's part of a application type problem that deals with this wording, is figuring out what that constant should be. We know at least it's directly proportional, so y is equal to some constant times x. Okay, let's take a look at the next bit and see what we can make with it. So y varies inversely or indirectly as x. Y is inversely proportional to x. These mean the exact same thing. Again, they have the same meaning, and what they mean, so these are synonymous. You could see this in a sentence or that in a sentence, but it means the same thing. And what it means is that y actually is directly proportional to 1/x, or the reciprocal of x. So that's what this means right here. So so y is maybe 1/2 of the reciprocal, or maybe 5 times the reciprocal. But whatever we see here, notice that like, let's look at this case up here when y was directly proportional. Suppose you have something like y is equal to 2x. That's an example of being directly proportional. Again, this constant could be anything. We're just talking about the generic idea. So if y is equal to 2x, say, that means that as x increases, since y is a proportion of x, y will also increase. So they increase together and vice versa. If this increases, that increases. Down here, however, notice, let's see, well, we still have directly proportional. Y is directly proportional to 1/x, right? So that means as 1/x goes up, y will go up, right? Yeah, and y go up, 1/x goes up. Except, what about x itself? Does x go up? It doesn't. X actually goes down. In fact, if you were to look at this graph, I mean, right here, y is equal to 5 times 1/x. That's just a stretch of 1/x, a vertical stretch. I mean, it looks something like this. Notice what happens. As y gets larger, what happens to x? X gets smaller. And as x gets larger, y gets smaller. Notice how we have that kind of relationship here. In this case up here, notice what happens. When this is, this constant of proportionality is always a positive number, by the way, so just remember that. Think of it as a positive number. So when it's a positive number, then we're going to get a positive slope out of it. And whatever that positive slope is, be it there, there, notice how it's always increasing, meaning as x gets larger, y gets larger, and as y gets larger, x gets larger. So we have that kind of relationship. But for an inversely proportional relationship, we have is one goes up, the other one goes down. Okay, let's take a look at the last one. Joint proportionality. So this, again, all of these actually relate right back to the first, directly with direct proportionality. We say y varies jointly as x and z, but what that really means is that y is directly proportional to the product x times z, meaning that y is equal to some constant multiplied to x times z. That's all it means. And sometimes we see this y is jointly proportional to x and z means the same thing. That's really all it means. So when the product goes up, y will go up. As y goes up, the product goes up. That's all it means here. Okay, so if you read this in a sentence, you know that your variables or ideas will be related in a formula in this particular way, and maybe you'll have to read the problem to figure out, to find some information that'll help you solve for what the constant might be. Okay, one last thing before we end this little short introduction to the idea of variation. What if we have things mixed together? For instance, what if we say y varies inversely as, so y varies inversely as t squared, but directly as x, say. So then how would we write this down? Well, again, if we see anything with varies inversely and directly, we're thinking of multiplication and division in a formula. So y is equal to things that are multiplied or divided. There's no addition in here at all whenever we're using any of these wordings here. So we have y is equal to some constant of proportionality multiplied. Now, notice you see the direct part. That means whatever's direct is in the numerator. Whatever's inverse is in the denominator. We're done. We just wrote the formula. So that relates these variables together just from the sentence. So kind of what this is we're practicing knowing what things mean in a sentence versus a formula here. Thanks for watching.